The next lesson in our unit is learning how to factor quadratic expressions. So remember, we saw quadratic expressions in factored form, which looks something like what we see here. Factored form is when you have the two sets of parentheses being multiplied together, and sometimes you have that a value, that coefficient, out front. So we're going to start with a reminder, even though we just did this yesterday, of how we get from factored form to standard form, and then we're going to go from standard form back to factored form. When we multiply these, we do our double distributive property, so we get x squared plus 8x minus 3x minus 24. When we simplify, we combine those two like terms in the middle. 8x minus 3x gives us a total of 5x, and then we have our minus 24. So think about where these numbers came from. The minus 24 came from the two numbers in the parentheses, negative 3 times 8. The plus 5 came from the two numbers in the parentheses being added together. That's where we got our like terms from. The negative 3 plus 8 gave us the 5. So when we factor, we think about what numbers multiply to the constant, the number without a variable piece, and add to the middle term, the coefficient of the middle term, that b value. Looking at our first example, the way that we factor these is with what's called the t-chart method, because we set up a t-chart, but it's not for x values and y values like you're used to using t-charts. It's for what numbers multiply to the constant, that number that's all by itself with no variable piece, and add to b, that middle term. So what we do is we think about all of the numbers that multiply to 14. We could have 1 times 14, or we could have 2 times 7. Then we take those same numbers, because the same numbers have to multiply to the constant and add to the middle term, and add them together. 1 plus 14 gives us 15, and 2 plus 7 gives us 9, which is what we want it to add up to. So we take those numbers that we just found in the t-chart, and we put them into the binomials. We put it into factored form. We have x plus 2 times x plus 7. That is the final answer. That is the factored form. What I'm about to do next is to show you how this checks and multiplies back to what we started from. Doing our double distributive property, we have x times x is x squared, x times 7 is 7x, 2 times x is 2x, and 2 times 7 is 14. So again, notice where all of these values came from. That x times x, we always get that x squared. The 2 plus the 7, those numbers we found in the t-chart, add to 9x, that middle term that we started with. And this plus 14 came from 2 times 7. Again, those numbers that we found when we did the t-chart. Notice our next example has a negative sign in front of that b. So we're still multiplying to 24, but this time we need to add to a negative 10. We have to keep track of those negative signs. So the numbers that multiply to 24 would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Looking at our list, it's really obvious that 4 plus 6 adds to 10, but the problem is they add to a positive 10, not a negative 10. The other way that we can multiply to a positive 24 is if both of the numbers are negative. Negative 4 plus negative 6 does equal negative 10. So when we factor this into our factored form, we have x minus 4 times x minus 6. I won't check all of my answers because hopefully after that first one, you understand how these equations are equal. They're just written in different forms. 2 more examples. Notice we do not have a number in front of our x term in the middle. We just have a negative sign. So we need to think about what we're adding to in that case. We have multiplication to negative 12, that constant value that's all by itself with no variable, and don't lose track of your negative signs. We're multiplying to a negative 12. And remember, the coefficient of x, if we don't see a number, is 1. So we're adding to a negative 1. The numbers that multiply to 12 are 1 times 12, 2 times 6, and 3 times 4. None of these add to 1, but then again, none of these numbers multiply to negative 12. So if we make one of the numbers negative, I'm making the bigger number negative because we're adding to a negative, so we want the larger number to be negative. 3 plus negative 4, the one at the bottom, does give us that negative 1. So when I factor this, I have x plus 3 times x minus 4. Again, that positive 3 times negative 4 multiplies to a negative 12, and the positive 3 plus negative 4 adds to the negative 1. And our last example, this time we are multiplying to a negative 16 and adding to a positive 6. So the numbers that multiply to 16 are 1 and 16, 2 times 8, and 4 times 4. To multiply to a negative but add to a positive, the smaller number needs to be negative. So we can see that negative 2 plus 8 gives us the positive 6. So we're going to factor this into x minus 2 times x plus 8. And you have 2 U-Try questions today.